Acceleration is, speeding up or slowing down, but more than that. If you want the physics definition, William, it's the rate of velocity change per second. I'm going to underline it. You don't bother because I'm not going to ask you this. I'm purely underlining it so that you know what the heck I'm looking at right now. What does that mean? Acceleration is how fast you're speeding up or slowing down, or changing direction, because acceleration is actually a change in velocity, and velocity has both magnitude and direction. So it's how fast you're speeding up or slowing down, or how sharp you're turning. Those are all included in acceleration. In Physics 11 and Physics 12, we're going to be looking at constant acceleration. Josh, I'm going to let you hit the brakes mathematically, or I'm going to let you step on the gas mathematically. But once you do that, I'm not going to let you give it more gas or step on the brakes harder. We can't deal with a changing acceleration right now. Changing acceleration really requires calculus. And so we will not look at a changing acceleration in Physics 11 or Physics 12. I'll mention them in certain situations. I'll say, by the way, the reason we're not looking at this is the acceleration will be changing, and we just don't have the math skills to handle that right now. So we'll talk about some. Where would that happen? Rockets. Really? Yes. So the velocity change per second, the acceleration is going to be constant, is the fancy word for unchanging. What are the units? Well, first of all, what's a good letter to use as an abbrev for acceleration? A. Lowercase. Uppercase A by itself is probably an area. Acceleration is a vector. And I said it was the change in velocity, delta V, per second over time. This is going to help us figure out the units, because what do I measure velocity in units-wise? What do I measure velocity in units-wise, or speed for that matter? Ooh, loud and proud, Ethan.
Meters per second.
So on the top, it would be meters per second. What do I measure time in units-wise? I'll give you a hint. He sort of said part of it already. Really, the proper units for acceleration are meters per second, but we're lazy. We don't write it that way. There's two S's in the denominator, the second per second. We write it as meters per second squared. Anytime you see a meter per second squared next to a number, Rodrigo, that's an acceleration. Now, I'm going to use the word acceleration to describe when you're speeding up or slowing down, because in physics, all acceleration means is that your velocity is changing. I don't care if you're speeding up or slowing down. Shouldn't you call it deceleration? We're just going to use acceleration. What would be a good way to show a backwards acceleration? Looking for a word that starts with the letter N. Yeah, we'll call it negative. And a forwards acceleration, we'll call it positive. Bada bing. Okay. Acceleration is a vector, but it's tough to visualize or interpret its direction. And part of it is, the reason it's so tough is, Connor, we get it confused with velocity. Even my Physics 12s, I can give them certain questions, and I can tell, even though I've said acceleration, they're thinking about which way it's moving, which is not the direction of acceleration. So the direction an object moves and how fast it moves, those are both velocities. Acceleration is how that velocity is changing, and to figure that out, you need to watch it for a while. We're going to do a little chart here. We're going to do this kind of intuitively, but see if we can spot the pattern. So it says, fill in the chart for an acceleration of 1.25 meters per second east. What would be a better way to abbreviate east, not a capital E? What would be a better mathematical way to abbreviate east and show it was different from west? I'm looking for it that starts with the letter P. We're going to call east positive. We're going to call west negative. Fair enough? In fact, I'm going to think of east as forwards. I'll imagine I'm in a car, and I'll think of west as the opposite of forwards, which is backwards. Okay. We're going to look at three situations. Situation number one, our VI, our initial velocity, is 0. We're starting at rest. Situation number 2, we're starting going forwards at 2 meters per second. You don't need to circle them. I'm just doing that so you can see which ones I'm talking about. Situation number 3, we're going to be going backwards at 2 meters per second. But in each case, we're accelerating forwards at 1.25 meters per second every second. Meters per second squared. So in this first chart, how fast am I going at time 0? What's my initial velocity as a number exactly? So all of us, let's put a 0 meters per second right there. And now we're going to step on the gas. We're going to accelerate. We're going to accelerate forwards at 1.25 meters per second squared, at 1.25 meters per second every second. How fast am I going after 1 second then? Do the math in your head. Yeah, I think you're right. I think, yeah. Yep. I watched your lips, so I was like, yeah, she's good. I'm going to put the positive just to remind myself that it's east, but I wouldn't be fussy if you didn't put it there because it's assumed there's a positive there. Mr. Dueck, as a lefty, you really make lousy S's. I do, and it's tougher to write on this tablet screen with this new crappy pen than you realize. I miss my old good pen that died about 2 weeks ago. But a new one costs $120, and as much as I love you, I'm too cheap to spend that kind of money. After 2 seconds, how fast are we going? Do the math in your head. Yeah. 2.5? I'll go positive 2 point, I'll even go 5.0 to give it 3 sig figs so that it looks like it has some kind of authority. After 3 seconds then, how fast will we be going? What are we doing each time to figure out how fast we're going 1 second later? What are we doing with that 1.25? Yeah. So 3.75 positive, yes? Connor, could you figure out how fast we were going after 4 seconds? Say yes. What if I wanted to know how fast we're going after 900 seconds? Do I have to figure out the previous 899, or is there a better way to get there? There's a better way to get there. Okay. B, now we're actually starting out moving. When we started timing this particular car, they were already going positive 2 meters per second, or 2 meters per second east. So after 1 second, how fast will they be going now? After 2 seconds, how fast? Positive 4.5, yes? And after 3 seconds, positive 5.75 meters per second. After 4 seconds, after 900 seconds, how fast would I be going? Can I get there in 1 step without calculating the previous 899? I hope so. This next one's got a little more teeth. I start out going backwards, so we'll call backwards negative 2 meters per second. If you look up, I'll try and mime this. Sorry for those of you who are watching on YouTube. So I'm going backwards, but what direction am I accelerating? Forwards. How's that going to work? Well, how fast will I be traveling after? You know what? I'm going to be slowing down. I'm going backwards, but if I'm accelerating forwards, I'm slowing down. In the backwards direction, I'm slowing down. How fast am I going to be going after 1 second then? Ooh. Oh, you're so close. I always have such high hopes for you, and then you crash them to the ground. No. What? Nope. Can't be 0.75. Negative. Because you're still going backwards, aren't you? We haven't canceled it all the way out yet, right? I think it's going to be negative 0.75. So the negative, Connor, which way are we traveling? Forwards or backwards? But not as fast. Okay? I have to be really careful, by the way, because in math, on a number line, that number is bigger than that number technically, because the larger the magnitude of the negative number, the smaller it is considered on the number line. So you're going to hear me picking my words, right? -5 is a smaller number than -4. But in terms of speed, -5, you're going faster as far as you're concerned than -4, and that's why speed is a scalar. I'll pick my words carefully to make sure I don't accidentally say the wrong thing, but I might once in a while. Here's where it gets interesting. After 2 seconds, how fast are we going? Positive or negative? Ooh. So Kyle, which direction were we traveling after 1 second, forward or backwards? What direction are we traveling after 2 seconds? There, I can tell you right now, sometime between 1 second and 2 seconds, I must have come to a stop and changed direction. Otherwise, how could I have been going backwards? How could I have been going forwards? So there's some good information hidden in here if I think about it as well. After 3 seconds, I think 1.75 positive. Yes, 1.75. What's the pattern? I think, because I wrote here, there has to be a better way. Please let there be an equation. I think it's you start with the initial velocity and then you add the acceleration times the time. And you can try that in your head if you want to. That's the equation we're going to derive a little bit from now. But first, let's talk a bit more about acceleration. So when the velocity of an object changes, the object experiences acceleration. Acceleration is defined as the change in velocity divided by the change in time. If I wanted to write it as an equation, I would go A equals delta V divided by delta T. Except, oh, by the way, you saw where I got the delta? It's on your formula sheet too, is it not? Where? Because you do have your green sheet out after I asked you to get your green sheet out a few times. Yeah. Is it front page top right? Yeah. By the way, while you're looking at it, what is change in anything? Always? It's on the top right. Someone read it. Sahara, go ahead. So if I wanted to turn this into an equation, it would end up becoming V final take away V initial over, and technically it would be time final minus time initial, but I think I've said to you, time, we're lazy. It's always a change in, and just over time, see how I did that? We've stopped writing the delta in front of time over time. Yeah, okay. That's the equation that I kind of typed up in the bottom box here. So if you want to, you can say A equals V final minus V initial over time. Is that equation on your formula sheet? Well, I think I gave you this one. Did I not? But I didn't give you this one. And there's a reason. We're not going to use this one. Yes, wow. We're going to use that equation, but we're going to write it prettier. This equation is a fraction, the math F word, not the F word you're thinking of. And most kids don't like fractions, so I'm going to rewrite it as a non-fraction, and that'll be our starting equation for finding acceleration. It's just easier to work within our heads. I think I've told you we are going to be doing a fair bit of math in our head. Yes? What was the symbol for acceleration? What was our symbol for acceleration? It's sitting right here, but lowercase a. What were the units? Meters per second squared. Meters per second is a speed or a velocity. Meters per second squared, that's an acceleration. Is it a scalar or a vector? Direction matters, because in one direction you'll speed up, in the other direction you'll slow down. Direction matters. I wrote a little blurb here. Velocity has the same symbol as speed. It does. V vector is velocity. V no vector is speed. If the velocity at the start of a time interval is VI and VF, change in, blah, blah, blah. Let's just make a little note. Change in anything is always what? Final minus initial. Yes? Velocity is a vector. Amy, that means it has magnitude and direction. So there are three ways to accelerate to change your velocity. First way is to speed up or slow down. That changes the magnitude. So if you're on a straightaway and you step on the brakes or you step on the gas, you're accelerating. The second way is to change the direction going around a corner. You're accelerating. The third way is to do both. Go around a corner while you're stepping on the gas or stepping on the brakes. We're primarily going to look at that first one in Physics 11 because we're going to stay fairly one-dimensional. Physics 12 will occasionally look at situations where you're accelerating by changing your direction, but your speed is staying constant. You're not speeding up or slowing down. How are you accelerating? Direction. When does that happen, Mr. Dueck, if you're moving in a circle? Example 2. Here's a question. It says this. A runner is racing in a 100-meter dash, and they accelerate from rest. Okay. Part of our strategy in solving physics word problems, we're going to look for numbers, but we're also going to look for physics phrases. And there is one phrase that you should get in the habit of underlining all the time, and it's this one right here, from rest. I'm going to say anytime you see it in your notes, underline it. Now, it's a bit of a lie. And by Christmas, you'll probably just be mentally underlining it. You won't be physically underlining it because literally when you see it, it'll be like it just screams out at you. You'll have taught your brain to ding, 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 ding. Take note of that. But for now, in our notes, anytime I see from rest. And what's this question asking me to find?
Average acceleration.
Mr. Dueck, why did you say average acceleration instead of just acceleration? Remember I said we can only handle a constant acceleration? Have you ever watched a sprinter, like on Olympics or in real life on a track or anything like that? Have you ever watched the 100-meter dash on the Olympics? Say yes.
Yes.
Pardon me?
Yes.
Okay. They don't accelerate constantly. Their fastest acceleration is their first couple of steps, and then as they start to hit their top speed, they're not speeding up as fast. It isn't a constant acceleration, so I put the word average in front, Matt, to hedge my bets. We're finding an average acceleration. We can't find the continuous at any one point acceleration because it's changing. We need calculus. So even though I said average acceleration, I'm just asking you to find acceleration. We'll treat it as though it was constant. But if you ever see that average acceleration, what that means is, Armand, I'm hedging my bets. Okay. Everybody write down A equals question mark. Isabella, have you written something down? Do you feel better? Are you more relaxed? Success is going up? Yeah. I can't call it a no-brainer, but you are going to find that the word problems in physics are significantly easier to rip apart than the ones in math. And specifically, what are they asking me to find? It'll usually be in the last sentence with the question word in it. Now we're going to look at numbers in physics words. Ange, I see a 100. What are the units next to that 100? So what's that a measure of? Mm-hmm. What's that 9? Yeah. Oh, a vector sign? Good catch. I'm not going to take marks off if you forget, and you'll find there's times where we ignore it and times where we're fussy, and you'll just get a feel for it. But yes, you're absolutely right. I owe you a candy. Don't let me forget. Hey, what's that 9? Yeah. What are the units next to the 9? Meters per second. So what's it a measure of? Now, from now on, anytime you say speed or velocity, I'm going to say which one. So from now on, if you're going to tell me a speed or velocity, you need to tell me whether you think it's the initial speed or the final speed. That's tough for me to teach. I'm just going to say to you, read the time flow of the sentence and use your grammar skills to dissect it. Is that 9 the initial speed or is that 9 the final speed? And convince me. Sorry? You're right. How do you know? And to speed of. That kind of implies a later. I don't know how to teach that part of it except to say just kind of read. So VF equals 9. What does from rest tell me then? Yes. I will almost never say to you, and the initial velocity was 0. I'll almost always say started from rest. What if instead of starting from rest, what if it contained the phrase came to a stop? What would the final be? 0. Okay, so that's another physics phrase we'll keep an eye out for. And the 4.5, what's that? How do you know? Second, yeah. This is why I've told you, as much as I hate memorizing stuff, it's worth memorizing what units go with what. I also did a quick check and noticed all my units are pretty. Meters and seconds. They match. What do I want to find? And what do I want to find? Yeah, that's why I put a question mark next to it. So I'm looking for an equation. It has to have an A in it. And then it's got to have some of these other things. Now, right now, you only know one, and it's that bad boy right there. Eventually, on Wednesday, by the end of Wednesday, you'll have 4 equations. Okay? And you'll get pretty good at figuring out which it is. I'll show you some tricks. But for now, we're just going to write down A equals VF minus VI over T, vector, vector, vector. Hey, by the way, why am I not putting a vector sign over the letter T? Because T is a scalar. This is why I said to you earlier, you need to memorize which ones are vectors and scalars, but you don't need to make flashcards. I'll keep repeating stuff like that, Mark, and as long as you're reasonably paying attention, your brain will just memorize it, because I'll repeat things. I'll repeat things. I'll say the same thing, but a different way. I'll repeat things. Okay. Ange, what's VF? Yeah. Keep going. Yep. Now, Dueck, it's 2. Yeah, but everybody get your calculator out. I'm starting with an easy one on purpose. To type this in, here's the next habit you have to develop. You need to always ask, Kai, is this a fraction? Say yes. Is there more than one thing on the top? Say yes. You have to put the top in brackets. Now, I realize 9 minus 0. You could ignore the minus 0, but if there were numbers there, oh, wow, did I botch that? I'd have to put that in brackets, divided by, Kai, is there more than one thing on the bottom? If there was, brackets as well. But I don't need to worry about that. The exception to this are those of you that have the newer Casios that have the double line display where you can do an actual fraction with a top and the bottom. You could ignore all this bracket stuff and good for you. Have I gone on the odd calculator rant about getting a decent calculator? I have? Good. And you get... Oh, that's because I typed it in wrong? Like that? 2. I could even go to a couple of sig figs if I wanted to. How would I write 2 to 3 sig figs? 2.00. Units, it's an acceleration. Yes. Okay. And then I often put a boxer on my final answer. That's kind of my touchdown dance. What value did I not use? What value did they give me just to muck around with my brain? I didn't need it. Turn the page. The stand, yeah. Can you wait for about 10? Okay. The standard unit for expressing acceleration is, Kai, once I finish talking about the music express, that will be your cue. What? Patience. The standard unit for expressing acceleration is meters per second squared. So if you're accelerating at 5 meters per second, 5 meters per second squared, that means every second your speed is increasing in the positive direction by 5. So if you start out at 2, after 1 second, 7. After 2 seconds, 12. After 2 more seconds, 17. Or if you start out at 6 and you're accelerating at negative 5 meters per second squared, 6 after 1 second, 1. After 2 seconds, you're going negative 4 meters per second. You're going backwards. There is another accepted unit of acceleration because of cars. Because car speedometers measure kilometers per hour, but engineers time in seconds, sometimes we can say that kilometers per hour per second is a unit of acceleration. I hate it. It's not the preferred physics unit, and so I've just decided right now, this moment, that I'm not even going to throw that on the test, because that's like fingernails on the blackboard to me. Other ways to write the acceleration equation. You could get the VF by itself. So the original equation that Ange gave us a few minutes ago, she said it was VF minus VI over T. And I'd like to get this thing here. I'll put a big red dot above it. The V final by itself. What side of the equation is the V final on? Left side or right side? Yeah. By the way, for that equation right there, that silly thing that you may have learned in science does not work, which is why I'm not a fan of it. It's so limited. Okay, what letters are on the same side as the V final? There's a T. Where is the T? Top or bottom? So is the T multiplying the V final or dividing the V final? Dividing. What about that VI? What's it doing to the V final? Subtracting. How would I move a VI over if it was subtracting? What's the opposite of subtracting VI? How would I move a T over if it's dividing? What's the opposite of dividing by T? I'm going to multiply by T. I'm going to add VI. The real question is, which one am I going to do first? And the answer is, I'm going to times the T over. It's going to look like this. There's going to be an A and a T. And then in my imagination, don't write that down, but don't write this next bit down. I'm going to imagine that there's still a VF minus VI. How did you tell me I'm going to move the minus VI over? So with your permission, I'm going to add the VI, and I'm also going to put the VF right there by itself. This is our final velocity equation. This is the one that I gave you on your formula sheet. VF equals VI plus AT. Find it. I think third line down, first equation, maybe? Yeah. In fact, that line has the big four kinematics equations, the ones that can be used to solve anything with constant acceleration. So this is the one I'm going to start to write down as my go-to. It has no fractions. Students like it better. Oh, how would I get the VI by itself? Okay. What side of the equation is the VI on? The right. How would I get it by itself? What's also on the same side as the VI? An AT? How would I move the AT over? How do you know? Someone said subtract. How do you know? Yeah. In other words, we're really doing your math 8 and 9 equation solving, just with letters, but it's the same rules. So the VF would just drop down like a domino, ka-chunk. The AT would get subtracted over, and then in my imagination, Connor, I'll write in my head equals VI, and then I'll say, you know what, why don't I put the VI by itself on that side, because that's where we're used to seeing it. What if I wanted to get the T by itself? Again, let's start with my preferred version of the acceleration equation. VF equals VI plus AT. What side is the T on? Right side, right underneath that red dot. What's the A doing to the T? How do I move it over? What's the VI doing to the T? Adding. I'll move it over. Which one am I going to do first? You know what? Look up. I'm going to argue that this equation is the same as VF equals VI plus AT. It's just got numbers, but the T and the X are in the same spot. So here's my question. If you were doing this equation, would you minus 12 first or divide by 3 first? Minus 12 first. You're going to minus VI or divide by A first? Minus VI. It's the same math as you did in grade 8 and 9. So I would end up with the VF just dropping down like a domino. I would minus VI. In my mind, don't write this next bit down, I would imagine that. How would I get the T by itself? Divide by what? Dividing by T would get the T by itself? Ah, and that's a common mistake. Don't do that one, because then you'll end up doing more work than you need to. So you're telling me that there's going to be an A down there, and if it's okay, I'm going to put the T equals right there, and vector symbol, vector symbol, vector symbol. Our bodies can detect accelerations. We have a built-in accelerometer. You can feel it. The only issue is you always feel it backwards. Whatever way you think you're accelerating, trust me, you're accelerating in the opposite direction. So I wrote here, most of us, all of us, have a built-in accelerometer. The only problem is it works completely backwards. Really? Yeah. We can prove it. Kai, you can go at the bottom of this page. Let's suppose you're in the passenger seat of the car at a red light and the driver floors it. Which way do you feel like you're getting pushed? Backwards? But which way are you clearly accelerating? Your body can detect acceleration, it just always feels it backwards. So you feel like you're getting pressed backwards, but I'm telling you, you're accelerating forwards. Oh, what if the car hits the brakes? Which way do you feel like you're getting thrown? But you're going forwards and you're slowing down, so which way must you be accelerating if you're slowing down while going forwards? Yep. You feel like you're getting pressed forwards. That's because you're accelerating backwards. Your body can detect acceleration. It just detects it backwards at all. How have you been on the elevator before? Okay, so when the elevator launches you up, Matt, you're clearly accelerating upwards. Which way does your stomach and your body feel like it's moving? Darn right. And at the top, when it shoots you downwards, you are clearly accelerating downwards. But which way do you feel like you're about to fly? Yep. So I'm telling you that so that if I ever give you a question about the direction of acceleration, if you can imagine your body sitting in that question, just ask, which way would I feel like I was getting pushed? I'm telling you it's the opposite direction, always. In fact, there's a ride at Playland called the Music Express. That's the one right by the pirate ship that goes in a circle really, really fast. And then the DJ says, who wants to go faster? And everybody says, no. And then you're going faster anyways. And you go faster and faster. Which way do you feel like you get pressed on that ride? Inwards or outwards? Which way are you accelerating then? Come on. Anytime you're traveling in a circle, you are accelerating inwards. That's a very counterintuitive one, but it's there. So you feel like you're getting pushed out. Trust me, you're accelerating in. In fact, when you're moving in a circle, we call it centripetal acceleration, and the word centripetal literally means pointing towards the center, center seeking. Why? Why does your body feel acceleration backwards? It's because on the inside, you're mostly water, and it's that liquid sloshing back and forth inside of you against the nerves that are inside of you, which is what your nerves can detect, and that's why it just detects things backwards. It just does. That trick works. I have yet to find, kids have tried really obscure examples. I've yet to find one where that doesn't work. A couple more, we're done. Example 4, turn the page. Did you all just turn the page? Let's be clever. Although we have our green sheet, just this once, let's write at the top here, VF equals VI plus AT, because this is the equation we're going to use for the next 3 questions. Read example 4 to yourself. Amy, what's example 4 want me to find? So which physics concept from that equation that I wrote at the top of the page is it asking me to find? Because none of those actually is called fast. We use physics words. Which one? It's definitely wanting me to find a velocity. VI or VF is the question. Which one? Really, VF? How do you know? What's VI? Now, everyone look up. Of course, by now, all of you underlined that phrase right there, right? And Amy, can you read the word in front of the word from? It starts with the word with the letter S. It starts with the word starts. So we're starting at how fast? What does from rest mean, folks? That's got to be VI because it has the word starts. So now that I know that, and it says how fast, as a process of elimination, if they told me VI is 0, which V must they be asking me to find? VF. So we put all that together? So what are we going to do, Amy? We're going to write down VF equals question mark. What's VI? From rest? Good. What's that 4.5? What are the units next to that 4.5, Amy? What do I measure in meters per second squared? Yeah. And I know it says the word accelerates, but can you see, even if I hadn't given you that word, if you saw the meters per second squared, you're good. And in fact, when my students get really good at this, they often don't read the English words. They look for physics phrases, and they're looking at numbers. Boom, 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 boom. Okay, so A equals 4.5. What's that 3.6? What are the units next to that 3.6? So, yep. And then, Amy, I would say, hey, I'm looking for an equation that has a VF, a VI, an A, and a T in it. Right now, you only have one primary equation. It's the one that we wrote at the top of the page. VF equals VI plus AT. So we would quickly rewrite it. What are we trying to find, Amy? So we want to get the VF by itself. Oh, hey, ha! Already is. Okay, that's a win. So now we're going to go to the plug and chug stage. Amy, what's VI? Plus A, 4.5, T, 3.6. It's going to be really close to 16 because this is really close to 4 times 4. What'd you get? Ange, what'd you get? Oh, you did type it in already. You're way ahead of me. 16.2. Units. Amy, it's a velocity. That's what it's called, but what are its units? Anyone, what are the units? Meters per second. And you'll get this because I'll be repeating this over and over. I'll be repeating this over and over. Shut up, Mr. Dueck. So your habit, though, that you want to develop, whenever you write your final answer, pause, units. So you don't forget that, because I will take a half mark off, and then I often put a little box around it. You don't have to. Cool. Cool. Neato. Alex, what's number 5 want me to find? Which physics variable in that 4-variable equation? Which variable is it asking me to find, though? Which letter is it asking me to find? VF, VI, A, or T? How do you know? You're absolutely right. And this is why I said it's worth memorizing units, because sometimes you notice the word time never appeared there. I didn't say how long, I actually said how many seconds. Oh, it's got to be time. So let's write down T equals question mark. What's yucky about this question? Have you spotted it already? Yeah. There's kilometers per hour, and there's also what? Meters per second squared. Now, if it was kilometers per hour, and then they gave me the acceleration somehow as kilometers per hour squared, I'd be okay. I'm going to have to do a conversion, and since they want seconds, I'm going to have to convert kilometers per hour. What is that kilometers per hour, by the way? It's a velocity. Which one? Initial or final? Really? What's V final then? How'd you get that? What's another word we should have maybe underlined if we were clever? There's another phrase you want to look for. So V final is 0. I'll take that. And V initial, I'm going to write 110 kilometers per hour, and then I'm just going to put an equal sign, convert it. Something to do with the 3.6. I can't remember what. Do you times or divide? I don't know. It's on my sheet. Did divide? What do you get? No, you don't. It's not what your calculator says, Connor. What's next to the 5? So would that 5 stay a 5 if you were rounding off properly? Or so I'm going to be fussy. If you're going to round off, don't chop off. So I'm going to write 30.6, but I'm going to store that on my calculator. And if I have to use it again, I'll just hit my answer button because it's less typing. It's more accurate, less chance of a typo. That's 3 wins. Okay? So I'm going to write 30.6. And that also would have bailed you out with your sloppy rounding. You still would have got the same answer because you would have used your answer button. So, well, you know what? It's Connor proof. There's a new adjective. That's terrible. Wow, I've never gone with that one before. That's a brand new one in my teaching. What's the 8 and how do you know? What are the units next to the 8? So what is it? A equals what? 8? For a candy, who can tell me why this is wrong? And it is. Who can tell me why it's wrong? There's a candy at stake here. I radioactive candy, don't I? Or something or other? This is wrong. Acceleration is not 8. Can't be. It's impossible. What? Are we speeding up or slowing down? How would I show slowing down? What do we decide? I like that question. I like that question. I like that question. That's a nice question. Now, if I want to make it a little easier, I could have told you that the acceleration was -8. That's, by the way, why I used the word magnitude. I did not give you a direction. If I was nice, I could have just told you the acceleration was -8, and all you would have caught it. But I don't have to be nice. I can be mean. Stick a negative in front of there, please. Good catch. Alex, I'm looking for an equation that has a VF, a VI, an A, and a T in it. There is one. We only got one right now, so we'll just drop it down. VF equals VI plus AT. Alex, what am I trying to get by itself? Look at what I have a question mark next to. That's why I do that, so I don't have to think. What am I trying to find? Look at what I have a question mark next. If you didn't write that, then you're going to start writing that every time from now on, because that one little step cuts down on things, especially if it's a multi-step question and you've been doing a whole bunch. You sometimes will forget, what was I looking for? Staring at me. What am I trying to find? Good. There's the T right there. What side is it on? Right side. The left side is going to drop down like a domino, so the VF drops down. What's on the same side as time? There's an A. What's the A doing? Adding, subtracting, multiplying, or dividing? So how do I move the A over? What's the VI doing? How do I move it over? Which one am I going to do first? It's going to be minus VI all over. Oh yeah, I don't want to divide by T, Sahara. I want to divide by A to get the time by itself. And do you mind, Alex? I'm going to put the T equals on this side. And I'm going to write, what's VF? 0, Mr. Dueck. 0 minus Connor. I'm going to write 30.6, but what button am I going to use on my calculator? And you need to know where that is. If you don't know where your answer button is, this is your chance to ask me, because it's less typing, less error, and more accurate. Triple win. You're going to get 3 point something. You're going to get 3.8 something. That's about as much I can get. I think 3.8 something. Or am I wrong? Oh, yeah? So let's go to 3 sig figs. I think if you use your answer button, you get 3.819444444. Is that right? So 3.82 if we round off and not chop off. Units, Alex, it's time. And you could have also figured that out because that's what they used in the question too, right? Last one. Anybody here own a Tesla in their family? I've taken one for a test drive. They go like stink. They really accelerate. The reason they accelerate so well is for a gasoline motor, if you ever step on the gas hard, there's a delay. There's a and then you slowly start to accelerate, but there's a delay. With an electric motor, it's instant. You have full acceleration, full torque, as they say in the industry, right away. So these are numbers from a Tesla. What's this question asking me to find? Yep. I'm going to write down A equals question mark. By now, you've all underlined from rest, right? What's from rest? Tell me, Isabella. Something 0. What's 0? Initial what? Yep. Good. Good. So, William, what's that 30 then? What are the units next to it? Meters per second. So what must that 30 be? Well, it's the velocity. Which one? Got to be process of elimination. Yeah. What's that 3.2? I'm looking for an equation, and I did a quick check. All my units matched, so I'm happy, Joy. I'm looking for an equation that has an A, a VF, a VI, and a T in it. It is VF equals VI plus AT. Now, Ange looked back at her notes because she didn't want to do this in her head. I am going to say it's worth learning to do this in your head because that's the skill we're going to build to. So, what am I trying to get by itself? Oh, A. Really? Sorry, I put the dot above the T right there. I'll just highlight that so you know what I'm staring at. What's going to drop down like a domino? Katoom, the left side. How am I going to move the VI over? How am I going to move the T over? Which one am I going to do first? And Ange, I didn't mind that you went back and looked because if you look what I've just written, I think we've come full circle. I think that's the acceleration equation that I put right here that we first got from defining what acceleration was. It's just the non-fraction form is a little prettier to work with. What'd you get? It's going to be 30. It's going to end in a 5, I can tell you that much. So how about 9.38 if I round off and don't chop off? Units. It's an acceleration. That was smooth. Meters per second. Dueck didn't say anything. Squared. Dueck didn't. Yeah, okay, good poker move. Meters per second squared. Okay. I'm going to be throwing a lot of homework at you. Take the weekend, work till the end of class. I'm also going to show you a video which is going to take us to the end of class. Take the weekend off. You can work on this Tuesday and Wednesday once school comes back. But also, there's going to be a few questions that you have. What's your homework? Here's what I assigned. Skip number 1. 2, 3, 4, 5, 6, 7. That was 2, 3, 4, 5, 6, 7. You can skip number 8. Hey, Dueck, it's not funny. How many of you been on California Screaming at Disneyland before? Number 9, I sat there with a stopwatch. Those numbers are accurate, so number 9, if you've ever won. It's got some pretty good acceleration, but not that big. I've been on better. 10, I'm a roller coaster nut, you'll find out as well. You can skip 11, 12, skip 13, 14. So Teslas, one of the nice things about the Teslas, oh, hang on, I need to pause the video because I can't put this online.